Okay, another video here. This video is going to be on magnetic induction. We discussed in the last video how a current carrying wire can be used or will create a magnetic field. In this video we're going to discuss how a current going through a magnetic field around a conductor can create a current in that conductor. So this time we're going to have a magnet by a wire, and we're going to create a current in the wire. The rule of thumb here is that if you have a wire, let's have a wire, and this time this wire could be going in or out of the page. You can imagine that you're looking straight through into the wire here. And you have a magnet. Let's say the magnet is sitting like this, north-south, and then you quickly remove it. Let's say you take it up or something like that, and so basically it is gone. That creates a changing magnetic field, and when we have a changing magnetic field, the conductor will create a current that tries to oppose the change or tries to maintain the magnetic field that was there. So in this case, a magnetic field going like that was there, and so if we put our fingers in the direction of that magnetic field, and then we try and put our thumb has to be below, so your thumb will be pointing into the page to make that happen, or the current will go in. So by removing the magnet, a current is created. This current will be short-lived. It'll actually decay exponentially very quickly, kind of with the same sort of pattern that you'd see with radioactivity or something like that. But as soon as it's gone, it'll start at some particular value, and then it'll decline until it's gone. So in order to make that current, we have to recognize that this word changing is really important. It has to be a change. Again, with this right-hand rule stuff, we can try again and do another practice here, but it's not really that critical what direction the current is created in. The important aspect of it for understanding technology and things like that is to recognize that a magnetic field is created, and for some reason it's trying to create the magnetic field that used to be there with the current. So this comes up most often in when we're trying to actually generate electrical power. So let's say you have a coil. This coil, here's your pencil again, just to give us something to wrap the coil around. And so, like I did last time, it's going to come out, so it's going across in front and behind, and then come, that'll be your last one, and then come out of there, sorry. And then it's going to go back from behind, so it's initially going by the front of the pencil before it goes behind. So what that means is that the wires will be going into the page on this side and out of the page on that side. It doesn't particularly matter though, really, what way the coil is. What way the coil is drawn. Now let's say you have a magnet sitting inside of that coil, and that magnet is on a pinwheel, so that magnet can rotate. Let's just pretend the magnet is rotating in that direction. Then at first there's a magnetic field pointed up, and so when this magnet starts to rotate, it'll try and reproduce upward magnetic field. In order to reproduce a magnetic field that's going up, if we put our thumb in the direction of the coil, we'll see that the current itself will end up going in this direction. Again, it's not really critical to see which way that current is going, but it would be going in on the right hand side and out on the left hand side. Alternatively, some time later with the North Pole down at the bottom and the South Pole at the top. Remember, this magnet itself is spinning. Then what's going to happen is that there's going to be a magnetic field that's going down. In order to reproduce that magnetic field, as that magnet spins away, then the magnetic field is going to be going in on the right, or in on the left and out on the right. Again, you can try and use your right hand rule to understand this. It's not really particularly important to see that which side it's going in on and which side it's going out on. What's important here is that now it's trying to reproduce a downward magnetic field and as a result it's producing a current in the opposite direction. So as this magnet spins, it's going to produce current in one direction and then in the second. So if we call this T1, then T2. But we can see here that after T2, it's going to, if this magnet continues to spin in this direction, this is really going to be T3 and T4. And if we were able to observe this current over time, what we would see is that the current would go in one direction, it would peak, and then it would fall off, and then it would go in the other direction, and it would peak, and then it would fall off, and again repeat itself over and over again. This might be T1, T2, T3, and T4. What that means then, what is this doing? What that means then is that the current goes in one direction, the other direction, and so it's an alternating current. So when we spin a magnet inside of a coil, that constantly changing magnetic field from it being up to down to back up to back down is going to create a current going in one direction, then the other direction, then back up to the original direction, and then down to the final direction, an alternating current. Alternating current is generated this way in all kinds of devices, but this is, how we actually create current in things like nuclear reactors or hydroelectric dams, or any one of those like a coal burning or fossil fuel reactor where we burn a fuel to create energy, which creates steam. That steam turns a turbine, and this is essentially what a turbine is, having the magnet go up and down and up and down and up and down. It's again, right now we're going to talk about the direction that would happen at different times. You can imagine that this is repeating itself over and over in time, and at one point it's producing the current in one direction, another point it's producing the current in the other direction. It doesn't really particularly matter which one is which. What is important is that the alternating current goes up and down as is shown. I guess the only other thing that's important to note just before I stop the video is that it is critical that you have a spinning magnet and you create an alternating current, because if you imagine a situation where you only pull the magnet out once or you only put the magnet in once, you wouldn't have a constantly changing magnetic field, and then as a result you wouldn't have a sustained current or a sustained situation of creating power. Well, that's it for this video.